Hello and welcome to our last lesson in the rational units. So again, another short unit, similar outline as it was to radicals. We learned about non-permissibles first, then we add, subtract, multiply, divide. Then our final lesson today will be about solving rational equations. Again, there would have been another lesson about word problems, which we're not going to do. So we're just going to end the unit with rational equations. Again, absolutely nothing new. It's everything we've been working with, so hopefully it's not that bad of a way to end this unit. Okay, so before we begin, let's just talk about rational equations. Again, everything up until now has been rational expressions, right? We've add, subtract, multiply, divide expressions. Now we have an equation. So what is a rational equation? Well, it's an equation that's going to have basically a fraction in it, right? Rational numbers are fractions. So a rational equation has the variable in the denominator. So an example, 2 over x plus 1 over 2x equals 10. So we have a fraction. Not only do we have a fraction, but we do have our variable in the denominator. And the variable we're solving for, that's where it is. So it's going to be a little bit fun to work with that. To solve, it's just 5 simple steps. Again, there's nothing new in the steps that we haven't covered in previous lessons. So step 1, list non-permissible values. You should be really good at that. You've been doing non-permissible values every single lesson, so you had about a week's practice of non-permissibles. That step should be pretty easy. Step number 2, determine the LCD. That should be easy as well. You've been doing that since probably, grade 7 and 8 math, and you've been doing that those 2 days when you did the adding, subtracting, rational expression. So that shouldn't be that hard. Now, step number 3. Step number 3 isn't hard, but this is where students will have problems. They're okay with step 1 and 2. Step number 3, multiply every term by the LCD. Well, that doesn't sound that hard. It's not, but it can lead to some confusion. If you've done step 3 properly, by the time you're done, my pen cut out a little bit, there should be no more fractions after you've done step 3. So if you've done step 3 and there's still a fraction, you either done something wrong and you're not done step 3 yet. So that's the key. After step 3, there should be shouldn't be any fractions. And then step 4 and 5 are easy. Solve and then check the non-permissibles. Now solving, the examples we'll do today are pretty simple solving, but solving could have quadratic equations as that solving step, but from what I've seen from your radical test, you guys are really good at solving, especially quadratics. Your radical test, really good work, really good setup. There weren't any E2 errors, so really, really good work, good quality work I'm seeing coming in even during remote learning. So solving could be any kind of solving at this point, and then check for non-permissibles. Okay, so not that bad, but I'll just warn you, step 3 is, just be careful with step 3. That kind of makes or breaks the question. Okay, so let's try 2 examples about solving rational equations. So for our first example, that's the same one we started with. 2 over x plus 1 over 2x equals 10. I see there's a glare on the screen, but again, you do have a copy of these notes with you, so hopefully you're okay. So what's our non-permissible? Well, here, x cannot equal 0. Here, x could also equal 0. So we only have one non-permissible, x cannot equal 0. What's the LCD? We have an x, we have a 2x, so the LCD is 2x. Hopefully that's okay for now. If you've done all your work from the adding, subtracting expressions, you should be pretty good at finding LCDs. Okay, step number 3. We multiply every term by 2x. Every term. So everything on the left and on the right. Sometimes students forget about the other side. Remember, we have equations now. You have a left and right hand side. So every term. Now there's 2 ways you can do that. You can multiply fully and then cancel, or cancel first and then multiply. I like to cancel out first. It just makes the math easier. But like I said, if you want to multiply then cancel, we should all get to the same answer. Okay, so we have a 2x on top and an x on the bottom. I'm going to simplify first. These x's cancel each other out, so then we're just left with a 2 times 2, which is a 4 on top. This step, we have a 2x, they both cancel each other out, so we are just left with 1. Now on the right hand side, 10 times 2x is 20x. Okay, now we're ready to solve, and this is an easy solving one. There's not even a quadratic equation here, so this is really easy. 5 equals 20x, so x equals 5 divided by 20. We can simplify x is equal to 1/4. Now we check. The good news is we don't have to do a t-chart like we did for radicals. We literally just check. What was our non-permissible? X can't equal 0. So as long as we get any value that's not 0, it's okay. So that is not 0, so we are done. So that's all we have to really do for our check. Okay, not that bad, right? Let's do one more example. So our second example, 7x over x minus 1 equals 5 plus 7 over x minus 1. Okay, step number 1 are non-permissible. Here, x cannot equal to 1. Here, there is no non-permissible, there's no denominator. Here, x cannot equal 1. Okay, so we only have one non-permissible, x cannot equals 1. What's the LCD? Well, that's easy. There's only one denominator, x minus 1, so it has to be that. Okay, step 3, multiply everything by x minus 1. So x minus 1, x minus 1, x minus 1. Then, can we simplify anything? Yes, we can. This x minus 1 cancels out that x minus 1, so we are just left behind with a 7x there. Nothing here cancels out, there's no denominator. And here, this x minus 1 canceled that, so we're just left with 7. So like I said, I think the key to success in this step is going slowly, carefully, and being organized. Sometimes students can't follow their own work, so just have nice, neat steps, know what you're multiplying, what you can cancel by. Okay, so then if we solve 5x minus 5, 7, we can combine our like terms. So we have 2, so then we solve x equals 1. Okay, now let's check. X equals 1, but oh, let's look at this. That was our non-permissible. So we should know right now, we call this an extraneous root. It's something that we solved, but when we check it, it doesn't satisfy the original. So what do we do with extraneous roots? We cancel it out. Now this is a little bit different. We only had one solution. We're quite often used to having two solutions, reject one, keep the other one. So what if we have one solution and we reject it? What do we have to say? We do have to write no solution. The solution is that there's no solution. Remember when we solved quadratic functions and when we had the graphs and they didn't cross the x-axis, there was no zeros? You do have to still say there's no solution. So the solution is no solution. If you stopped here, I cannot give you full marks because you haven't really answered the question. So your solution is no solution. Okay, so you can try this. This ends the rational unit. We'll do the same thing. I'll give you a little mini test that summarizes everything, and I'll give you a few days to hand it in. Again, good work on the radical test. Fantastic work, steps. I know this is tough and not ideal, but you guys made it through that radical unit and did really, really well. So I know that you'll do just as well in the rationals. And again, keep emailing me and contacting me if you ever have questions or need help with anything. Okay, good luck on your test.